Welcome to this video. In this video, I want to look at the relationship between mass and weight. So we have produced a video that has helped us to see the difference between mass and weight, and you do well to visit that video to appreciate the difference between mass and weight. So in this one, we want to look at the relationship between the two. The relationship between mass and weight helps us to come up with the equation that helps us to know that mass and weight is related by this equation, where we say weight is direct proportion to the mass of an object. Of course, g is the acceleration due to gravity. Now, in the first video where we have explained the difference between mass and weight, we explained that weight differs from place to place, while mass is the same everywhere. So why is it that weight differs from place to place? Well, it's because of the g value, the acceleration due to gravity. Acceleration due to gravity is different from place to place. So let's take, for instance, for the Earth, the acceleration due to gravity is rounded off to 10 meters per second squared. Then on Moon, the acceleration due to gravity is rounded off to 1.6 meters per second squared, while in the space, the acceleration due to gravity is 0 meters per second squared. So you'll notice that these three places we have highlighted have different acceleration due to gravity. So because of this difference, weight of an object should be different from place to place. Let's look at an example. So let's get an example. We want to see how weight is different from place to place. So imagine we have an object with the mass 200 kg. Then they ask us to find the weight of this object on Earth, on the Moon, and in space. So let's start on Earth. What will be the weight of this object on Earth? Remember, the formula is weight is equal to mg. So our m is the mass. We have the mass is 200 kilograms. We are multiplying it with the acceleration due to gravity on Earth, which is 10 meters per second squared. When you multiply the two, you will get 2,000 newtons. So this is the weight of this object on Earth. What of on the Moon? On the Moon, what will be the weight of this object? Remember, the formula is weight is equal to mg. So the mass of this object is 200 kg. We are multiplying it with the acceleration due to gravity on the Moon, which is 1.6 meters per second squared. What will be the answer? We will get 320 newtons. 320 newtons. Then let's look at in space. What will be the weight in space? Remember, the formula is weight is equal to mg. So our m is 200 kg. We are multiplying it with 0 meters per second squared. What are we going to get? We'll get 0 newtons. So from this, you can notice that we have 3 different weights of the same object. And this is because of the difference in the acceleration due to gravity. So this qualifies why we say the mass of an object is the same regardless of the place where the object is, but the weight differs. So remember, the formula for weight is equal to mass multiplied by acceleration due to gravity. Acceleration due to gravity differs from place to place. Hope you have found this video beneficial. Don't forget to subscribe to this YouTube channel and the Facebook page for this